Good morning, good afternoon, good evening, everybody. Welcome to the first live workshop of the AI Festival. This session, just to make sure everybody's in the right place, is about AI in the energy sector. And we have three very eclectic panelists today to discuss and debate some of the different aspects of AI in the energy sector and how it will impact this rather strategically important sector. The layout for the next 45 minutes is fairly simple. I'll do a brief introduction of the session and an overview. Then I'll ask each panelist to introduce themselves, provide a bit of background, and also to give kind of a high-level overview of their view of AI in the energy sector. And then we'll move to a Q&A session. And I think we would all agree that the energy sector is strategically important, not only to countries, businesses, to individuals, as we've probably recently seen in Texas with rather severe snowstorms. If you don't quite get it right, it can be quite catastrophic. And so some of the areas I'm hoping to cover off in these next 45 minutes is around, the three main tenets of the whole energy sector. There's about power generation, there's about power storage, and there's also power consumption. But then wrapped around those three key tenets as well, you've got how do you balance the demand and the supply? And then on top of that, wrapped around that as well, you've got this transference of using renewables and sometimes nuclear, sometimes fossil. So how do you move between those? And then underpinning some of this, you've got some stuff around energy trading. This is becoming a really hot topic as companies and regions and markets actually trade energy amongst themselves, which is a really interesting dynamic. And then you've got the whole green energy agenda and what that means as well. And as this is really about AI, at the end of the day, what if it goes wrong? Do we have explainable AI to kind of describe what we think is going to work here when it's all said and done? So from my perspective, this is a very, very, very important section and one of the most strategically important industry segments we've got. And I think AI will have a huge impact in that area. So what I'll do now is I'll go to our three panelists and I'll let them introduce themselves accordingly. And what I'll do, I'll start. Will, can I start with you? Will Hitchcock?
Sure. Hi, everyone. Will Hitchcock. I'm founder and CEO of Above. And so just quickly, my background, engineering background, then spent most of my career working in software engineering, not in the energy industry. Always had a bit of an interest in renewables and solar. So I joined the sort of UK solar industry boom back in 2014 when utility scale solar was really taking off. I set up Above in late 2015, early 2016 to tackle a problem or a challenge in the industry as the assets were getting bigger and bigger, the solar assets. The challenge of carrying out health inspection of those assets was becoming a bigger and bigger problem for the traditional ground-based approach. So we really catalyzed the use of drones in the solar industry and delivering aerial thermographic inspection services at scale. And very quickly, once you've fixed the problem of collecting images of tens or hundreds of thousands of solar panels, you've then got a problem with how you process that data. So from the very beginning, we knew that the answer lay in computer vision and AI. And since that early beginnings, we've been working with the University of Essex computer science team on a number of sort of collaborative projects to develop that capability. And we've gone on as a company to deliver thermographic inspections, visual inspections, as well as kind of digital twin technology to the industry. And we're now operating pretty much wherever solar is being deployed in the world, which is typically everywhere except for the poles. Yeah, that's probably enough about above.
Great. Well, thank you very much. Nidhal, can we move over to you?
Thank you, Mike. Hi, everyone. I'm Nidhal Zribi. I'm head of R&D digital innovation at EDF. So I've been working with EDF Group for the past 10 years, mainly in the IT function and now in the R&D space, where I lead a team of data scientists, AI scientists, and digital innovators developing new projects in blockchain, in augmented reality, but also lots of machine learning and deep learning models that I hope I'll be able to share some of them with you guys today. And before joining EDF, I used to work in the design thinking lab at the French TSO Enedis, where we look after developing new innovation that deliver value to end users, focusing on the customer's needs, pains. And this is very important in my opinion when we're looking at cutting edge technologies such as AI. The main purpose should always be treating a problem, finding some solution to a very challenging problems that we have in the energy sector or any other sector. That's
Great. Great, Nidhal. Thank you very much. And last but by no means least, Andy.
Yeah. Andy Rowland. So I head up digital manufacturing within BT's global division. So I've spent about 35 years in IT. Before that, I was in accountancy, which makes me sound very, very old. But I'm very interested, for the last 20 years, I've been looking at new business propositions. And 3 years ago, because of the customers I tend to talk to, we started looking at Industry 4.0. So hence the digital manufacturing. So we've been very interested in terms of actually how we can use AI to drive efficiencies for our customers. Globally, we have probably about half of our big global multinationals are in the sort of manufacturing, resources, logistics space. So big interest in driving efficiencies, so operational efficiencies, improving quality. But what has come to the fore, certainly this year, has been around energy efficiency. So we've been doing a lot of work looking at using AI with partners to effectively calculate almost like an energy efficiency index. So to look at for any particular type of production or any type of process to baseline it, and then using the AI effectively to act as like a coach to actually help people to achieve what they call in manufacturing a sort of golden day when everything absolutely goes perfectly. And to be able to keep sort of nudging people in the right direction to reduce energy and reduce carbon. So it's become a really big focus area. We've got lots of customers at the moment who are looking at starting to deploy this. And a lot of what we do is actually all around supporting infrastructure to make it happen and make sure when you connect all the data, you can do it efficiently and you can do it securely. So different perspective, but very much looking forward to the discussion today.
Great, Andy. So what I'll do, I'll move right into asking some questions. We had some questions pre-submitted, and the first one's quite topical at the moment. You may have seen the ice and snowstorms in Texas took out the totality of the grid. There was multiple reasons and excuses as to why it happened. You had one group saying, "Oh, it's because there's too much in renewables." You also had another group going on, probably more realistic, talking about how it froze up some of the natural gas pipelines and so forth. So for me, it's about the meteorological impact on being able to, on the generating assets and how these assets could perform in different weather conditions. Climate change is what it is, whether you believe it or not. So given the fact that we think climate change is happening, the fact that we're seeing some unusual weather conditions here, do you guys have a view on how AI can help with this change in meteorological conditions, as well as the change in the sources of the generation of the power as well? And Nidhal, if you don't mind, I'll start with you on that question in the first instance.
It's really an interesting one, Mike. In the past years, we used to have a very simple energy system. We used to have power station that will produce energy, send this to the grid, and then through the transmission system to our homes. But now we will have renewable energy that will produce energy when the sun shines or the wind blows. We will have electric vehicles. We have even vehicle-to-grid vehicles, which can charge or discharge from the grid. We'll have power capabilities in the kind of consumers side as well, with the possibility of using your own energy that you talked about. So I think it's all this complexity of the new energy system with the climate change, with all of the uncertainty that we have, couldn't be tackled with the classic energy, pure energy engineering system that we used to have. And we start to see lots of debate on the energy sector, for example, in the UK, with the government looking after how we can empower the use of data. And I think this is the key to avoid maybe in the future this kind of events by anticipating with sharing more data between the different stakeholders, sharing the more hypotheses, sharing the different scenarios that could avoid such things to happen. There is an example of in August 2019 in the UK, where we had also a kind of a mini blackout in London due to a renewable challenge. So I think AI could be a good asset to help us understand what's coming, thanks to the data that is available and the huge amount of data that we have today, combined with the computing capabilities that we have, combined with the cloud that will allow us more sharing. But AI can understand very faster than human what's out there, and maybe predict the future or predict scenarios that we human can decide what we do with it. And we'll see maybe in the future some of the work that we're developing at the moment could allow us to do some of that.
Great, Nidhal. Will, do you have a view on that one?
Yeah, so three main areas really. One is, so with the Texas event specifically, I think that was just an extreme weather event that was so extreme for that area that they just weren't prepared for it. Infrastructure wasn't ready. So that's the first thing, is to get better at predicting how our weather patterns are going to change and to provision the right kind of infrastructure to be resilient to it. But the other thing is around, you opened up the point, and there's all of this kind of talk of outages and the intermittency of renewables. But I think the whole renewables thing comes with distributed energy. So once you've got distributed energy, you're building in resilience into the system. So the more distributed our energy, the more sort of points of generation there are across an area, points of storage, the more resilience and redundancy you're building into your system. So I think ultimately, when this, as this sort of transition matures, that it'll be a more robust infrastructure provision of energy, if you like. But absolutely, AI is going to play into all of the different sort of dynamics of electric vehicle storage, and sort of usage profiles of certain areas of conurbations, but also being able to predict not just extreme weather events, but how weather is going to impact the yield produced by a solar farm in Devon as a weather front comes through, and a wind farm, and being able to manage supply and demand at a much more granular level based on the knowledge of what's going to be produced under a specific weather pattern. And those algorithms and that knowledge is growing massively, and it's a big area of focus for the kind of energy distribution industry. So I think, yeah, this is all improving all the time, and I think it will build a much more resilient energy system compared to centralized.
Yeah, great. Thanks a lot, Will. Andy?
Yeah, I think there's building on what Nidhal and Will have already said. I think there's a lot of potential to use AI for risk modeling. I'm conscious from conversations sitting in the UK that we've probably got less room for manoeuvre than we had previously. So in terms of, Nidhal talked about some of the outages, it wasn't, it didn't take a lot, unfortunately, for there to be sort of some fairly significant blackouts. So I guess there's a debate around energy storage. I think there's a debate around actually using AI to look at just in terms of equipment, more sort of predictive maintenance to avoid any sort of unscheduled, unplanned downtime that can have a major impact. But I think just in terms of broader risk modeling as well, and we use AI extensively within the cybersecurity space to deal with things we've never seen before, and to be able to manage those so that it doesn't get out of hand. And I think some of those skills could be repurposed into looking at extreme climate and how that affects our infrastructure. So I think probably need to think of it quite broadly in terms of looking at AI from different aspects and how it could actually help us to address some of these challenges.
Okay, great, thanks. And so all three of you mentioned this whole ability to be able to predict and detect using AI. But I think, as we all know, AI is also dependent on, I guess, clean data or good data in the first instance to actually develop the models to be able to do that. With the energy sector, we're dealing with legacy systems, legacy companies here, and their data is not always as clean as we would like. So how do you see us actually bridging that gap between, I wouldn't say it's corrupted data, but dirty data, and then trying to get the right kind of predictive and detection models in place to stop these kinds of things in the forward? And Will, I'll come to you first with that one.
Yeah, so I mean, I can only really speak sort of in any detail about the solar industry. I think sort of the Internet of Things plays a role in this, and big data in terms of collecting weather and generation information from assets. And so the challenge for modeling solar asset generation for a given sort of weather pattern comes from being able to see how that asset has behaved under certain weather events previously. So that sort of temporal data is really important. So we need to get better at aggregating that temporal data to be able to power these algorithms to make any sense of it. So, but I know that is a thing that is happening across the industry now. So I know that the solar industry, there were times during last sort of summer where I think over 35% of our electricity was coming from solar. So solar has become a significant part of our energy mix in this country, and it's something we should applaud ourselves for. But that brings with it the challenges of being able to manage that intermittency. So I'm aware of a number of initiatives going on in that area to improve the monitoring capability at particular plants, and then the sharing of that data to power these algorithms.
Great. Nidhal, your view on that one?
I don't know if you remember, Mike, in 2017, the Economist made a statement, data is the new oil. And I think since then, there was many debates on why this is a bad thing. But when you look at it, you see that not just having a clean data is a must to build effective data-driven models. It's also being able to access it. And in the energy sector, it's so protected, not really shared as it should be. This is the statement that is made by BEIS as well in the UK, and this is what's behind the Modernizing Energy Data Infrastructure program that the government just outlined in the white paper released end of 2020. And this is basically what will allow us tomorrow, by more data sharing, to use AI and data-driven technologies to see new business models that are being developed in the UK and maybe wider, and also to see a mix of data from the energy sector with other sectors and see maybe different offers that are combined, maybe in the telecommunication and energy offers, for example, for customers and things like that, that will offer more choices for them, and also for our assets by accessing more skills, by sharing our data, will allow us, I think, to leverage the power of AI. But without sharing clean and high quality data, we will still struggle with that.
Okay, great. Andy?
Well, certainly the models we're looking at, we use training data initially to build the models, and then we'll then do further use further data then to actually test it to see how they work out. But one of the key things actually is putting human beings in the loop, so bringing in experts. So if we're looking at, say, something like energy optimization in a steel plant, then the AI can make some recommendations. It can look at previous behaviors. It can look at the data that it's got in terms of, sort of the useful work vis-a-vis the energy that was used and the calorific value of different sources and, different settings. But then ultimately, then it's important to get the engineers in the plant to say, actually, does this make sense to you? How do you want to set values? Do you want to set minimum, maximum safety values? So you can build on that expertise as well. So you sort of you bring the two together, I guess, and that gives you a bit of a safeguard in terms of if there are problems with the data that you might not initially pick up purely with the AI. So I think getting human in the loop works quite well, from our experience, particularly also actually in getting things successfully deployed as well.
Okay, great, Andy. So you mentioned the human in the loop. So I'll ask one more question to the panelists. And I've got some questions that have come in from some of the other participants. But the minute you mention AI, machine learning, and those kinds of technologies, the first thing people say, it's going to take jobs from people. It's going to, reduce the number of people involved. And Andy, as you said, there's got to be human in the loop here. So do the three of you have a view in terms of what the impact may or may not be on not only people using the AI technology in this sector, but also the impact of keeping people in the loop as part of that AI approach? And Andy, I'll come to you first on that one as well.
I mean, I'd give you an example, actually. So we had some feedback to our CEO from a CIO, one of our major clients, and they'd done a project with a big consultancy firm. It was an industrial environment. They brought a load of data scientists in. They sat down. They did a sort of whiteboard session, post-it notes. Tell us all about your business, how it all works, and then here's the model. Go and deploy it. And they said the feedback was extremely negative. The people in the manufacturing environment, the experts who've been doing it 10, 20 years, they said it felt like something was being done to us rather than actually with us fully involved. So our approach is very much actually to use AI to build an algorithm, but then actually to work with the particular individuals in a particular sector to build a model. So they actually feed their own data into it. They're fully involved in it. It's completely transparent. So it's not like a black box. Here it is, go and deploy it. It's completely transparent so they can understand how it works. And if they understand how it works and they've been involved in actually the deployment process, then they're far more likely then to trust it and for it ultimately to be closed loop. So we've got some implementations now where the AI every 30 seconds optimizes the energy and say something like a cement kiln, which use loads of energy. But you have to build that trust and get people involved very early on if you wanted to get a successful deployment. And our view is that we refer to it more about augmented intelligence rather than artificial intelligence, and getting the AI from the data scientists actually into the hands of the engineers. And I think that's really, really important from our experience.
Great. Thanks, Andy. Will?
Yeah, so we're on a sort of a constant agenda of reducing the human in the loop, and this isn't about reducing overall. This is about doing more with less, because the solar industry particularly, is quite unprecedented. 80% of the maintenance and operation costs of a solar plant is human resource, and the assets that we're now monitoring are humongous in scale. So to contrast 10 years ago in the Italian solar boom, where a typical plant was 1 megawatt, that would have been about 4,000 panels. We're now inspecting assets, one in Australia, 350 megawatts. So that's 800,000 solar panels on 900 hectares of land. And that is a huge human cost to try and identify issues and make sure that your time on site is optimal. So it's absolutely vital for the industry to reduce the sort of wasted time of human resource. Solar is unique in the energy space with that high level of human resource cost. So when it comes down to the specifics of what we're doing in terms of health inspections of the solar panels, we might be turning 800,000 solar panels into 2,000 of note to go and be looked at closer by the person on the ground. And that is a significant saving in costs and just targeting the resources in that way. And the other thing that we're doing through our algorithms is that we're generating predictive analytics. So the more and more data we can bring, the more insights we add, initially coming from human intervention, we can then start to drive out and power predictive analytics. So we can start to forecast rate of degradation of modules and predict where some of these issues are going to arise in the future. So it's absolutely key for the industry. And it's an agenda of the industry because solar is being deployed at fantastic rates. I think the European solar market will grow fourfold in the next 5 years. And so that rate of deployment and the scale of the assets absolutely requires these technologies to be applied to make it competitive in the energy mix.
Okay, great. Thank you, Will. Nidhal?
Yes, as Will said, I think we're far away from an autonomous system that is monitoring a power station, for example. We're developing an AI that is helping engineers, supporting them in their daily jobs. So similar to what Above does for the PV panels, what we do, for example, with machine vision is to support the engineers in the inspection of the wind turbines. And you know that's a very tricky part in terms of maintenance of our assets. So when you have to look at more than 20,000 photos of blades of the wind turbines to identify cracks or damages, an AI could be really an added value to the engineers, and we're building that with them because they have the knowledge, and it's for them to be able to faster identify areas where we can reduce the loss of power that these turbines are meant to produce. The big question is always on the call centers as well. So we work with our colleagues in the call centers because I don't think that everyone appreciates the experience of just talking to a chatbot or a robot when it comes to understanding something that is going wrong with your account. So you need always this human part. But what we're building with chatbots and mini autonomous systems is really to facilitate the first interaction, to help the call center and the advisors there to get quicker to the problem and to be able to serve our customers and to help them. So we're developing tools that will automatically recognize what's in the emails of customers in the complaints to try to identify areas where we can target our let's say action plan to increase customer satisfaction, because that's what at the end of the day we would like the call centers to focus on. So it's more of in the real world application and not science fiction. It's really to help people save time and cost.
Cool, great, thank you. So I want to turn to some of the questions that has come in from the participants, and I'm going to throw this one out to the panel generically because I'm not even sure I understand the question. So Will Purchase has asked the question. So he's eager to learn more about the concept of agile fractal grid. So who wants to deal with that one first, or if you guys like me going to admit, I don't even understand what he means, but I don't work the energy sector.
This is distributed energy and microgrids, right?
Yeah.
I think I'll hand over to Nidhal.
That was a quick.
Yeah, well, so this is not something we're looking at the moment at EDF in the UK, but part of EDF group, we have different research area in the microgrid. And we have, for example, in Maseira in Singapore, in a small island, a whole microgrid that has been set up by EDF and its partners. And we run lots of tests there. And part of that, we are trying to use AI and autonomous system to look after distributed energy and different application, even peer-to-peer trading, things like that. So it's being looked after, but not in the UK.
Okay, so if I'm understanding the question correctly, what you got is a series of small microgrids. So you have to be able to balance the supply and demand between those different grids, and you would be using AI to be able to manage that. That'd be fair?
Exactly, and optimize the use of the batteries, for example, because we do battery storage, and when you would like to kind of use the energy or sell it or share it, there's lots of areas where AI is helping us with that.
Okay, great. It sounds to me like it's really leading edge stuff as well.
It is, and this is why it's really in the R&D space.
Okay, cool. I've had one other questions, and I'll apologize if I don't pronounce the name correctly. So Wenjia Wang has asked the question, roughly what is the percentage of electricity that is generated by wind turbines, and what AI technique has been applied to wind turbines and for what purposes? And so she's asked if I direct that towards Nidhal, but also, Will, I think we need to look at the solar aspect as well. On this as well. So Nidhal, if you want to address that from a wind turbine perspective.
Yes, I don't have the numbers. I have to Google that, but it's I think it's less important in France than in the UK, because obviously we have lots of capacity thanks to nuclear, but it's an area where we developing floating wind, offshore wind in the UK is very important as well. It's increasing if you look at the Boris Johnson 10-point plan or the energy white paper. So what we do in the area in terms of R&D, because this is where I come from, what we do in the area of renewable is really to increase the capacity of production, of deploying the assets in the floating wind, for example. And AI can play a role in terms of optimization, and this way we will be predicting the capacity of power generation, which will be helping EDF, the grid, energy trading, but also in terms of the maintenance. So at the moment we're looking at photos underwater taken by small drones to understand how life is going underwater and around the turbines, and how is this going to affect the power generation. So this is very new for us. We use machine vision underwater. We try to understand how this will work to affect what I'm trying to say is what we look after is really to maximize the profit from the wind turbines that we are deploying in the water or in the ground.
Okay, great, Nidhal. So Will, from a solar perspective, same question.
So I do have the only statistic I could regale now is that I think it was 33 or 35% of electricity was coming through from solar for a sustained period during the summer and the spring last year. I think the actual, the capacity of solar compared to everything else is quite low, probably single digit percentages. But actually, at certain times of the year, then solar can dominate. And yeah, I mean, you have to look at the energy system in its entirety when you're looking at how AI can improve the benefits of solar. So more and more assets in the UK and across Europe are now being deployed with containerized storage solutions. And those storage solutions are there not only to, they're there for two reasons: to make the project more financially viable, because then you can use that stored energy at higher energy prices, but also it just extends the use of solar, across the 24-hour period. So every time you can level that peak in demand, then you can reduce the use of fossil fuels. But I think in terms of the overall energy system for the UK, it has to be looked at in the round. And yeah, as we discussed earlier, AI is certainly playing a part in how you manage that battery storage, how you manage the decisions you make about use of that storage are folded in with weather predictions and demand predictions, which are all powered by AI. So understanding those demand profiles and an imminent weather pattern over the next 24 hours will help maximize that solar energy in our grid, in our system. So yeah, it's a bigger picture thing than just aligning it with solar.
Okay, great. Well, that kind of brings me on to a bigger question that's been asked by Tim Robinson, and he's asked me to direct it towards Nidhal. But once again, it's for the whole panel to answer. Is about how effectively do you think the energy industry and the digital AI community are working together to tackle the energy sector challenges? So, do you think there is scope for greater collaboration across the sector? So, Nidhal, I'll start with you on that one.
It's a good question, and I think it's one of the challenges that we face at the moment. So I think there's more than 40 competitors in the UK in the energy supply, for example. But the government is doing a really great job on this, on bringing us together. So recently I attended a workshop organized by the Center of AI for climate change, and it was really interesting because we had lots of suppliers, energy networks, the national grid, and we all shared the challenges that we're facing in terms of trusting each other to share more data and to bring value out of that. And clearly things will evolve in the future because regulation will evolve as well. And I think in the coming years, energy companies will have to justify themselves for not willing to share their data, and which is the other way around than just protecting that. And I think what's important to see is once data shared, great value can come out of it. One example is the national grid shares the carbon intensity of the grid in the next 48 hours. And this is very interesting because we use that data. So it's an open API, we take it, we use it, and we inform our customers about that with an Alexa flash, with an detailed information about what they can do to change their behavior. And this way, they will use energy when there is less CO2 emission in the power mix. And it's a very interesting insight. We didn't have this in the past. We couldn't inform customers when it's best to use energy, when it's best for the planet. And things like that we'll be able to see that thanks to the Modernizing Energy Data program. Yeah.
Okay, great. And Andy, given your role working with a huge range of commercial companies, do you have a view on that one?
Yeah, I mean, in terms of sharing data, I mean, that's something I touched on earlier, but obviously all of this is part of critical national infrastructure. So I do think it's important actually to have highly granular data that can be shared, because some of our researchers are looking at what we call adversarial AI. So where you can get organized criminals or particularly state-sponsored attacks looking at actually corrupting the data. So the AI that you trust and you rely on then starts to behave in the way that it shouldn't do. So I think there's because it is all very critical national infrastructure, certainly the customers I'm seeing, they're seeing cyber attacks on industrial systems, even for the first time in the last year, things like safety critical systems. So it's gone from sort of disruption, ransomware to potentially harming people. So I think that wider sharing of data, I think across the whole sector is very important. I think there's lots of people who would benefit, and I think it's also important from a national security perspective as well.
Great. And Will?
Yeah, I mean, I think yes, we can definitely improve how we share and use this data, but we're on a real journey here with all of this. This is quite a seismic shift in how we provision energy, and down to smart metering and smart white goods, all the way up to planning weather events and how that's going to impact some of the intermittent generation. All has to be looked at as one massive kind of ecosystem. And I think at the moment you're just seeing the electric vehicle sort of deployment in the UK starting to take hold, and that's going to come with its own challenges, which are very much focused on the electric vehicle sector. But then it's about how we combine that in the conversations about how we're provisioning power in general. So yeah, I think there's a lot more to do, but there's huge gains to come out of this. But it's going to take a while before there's all of that sharing and trust and understanding of how all of this stuff interacts with one another. But yeah, it's quite an exciting journey when you think about how quickly this has become a thing. In really embracing the energy transition to distributed energy, it's literally within the last 5 years is only when we really started to grasp some of these concepts. So I think we've come a long way in 5 years, but there's a heck of a long way to go.
Okay, and I've had kind of a follow-up question to that about does the panel see a significant role in innovation for startups and SMEs as well as large businesses in this space? So Will, I'll start with you because I think you kind of fit into that SME startup space. So do you have a? So I'm assuming your answer is going to be yes, but
Yeah, I mean,
but
it's
is
quite
there
interesting. I keep swinging it back to the solar industry because that's the industry we play in, right? But the solar industry is quite unique in that there are a number of the ecosystem is quite different to other energy sectors in that there's a lot of players within the life of an asset. There's the developer, there's the EPC who construct it, there's the O&M company, there's the asset management company, there's the fund that own it, and then all these assets are SPV, so they're kind of tradable assets, and that ecosystem kind of it's sometimes a difficult thing to work with, but actually it creates a lot of opportunity. So a lot of the industry, the solar industry, is made up of SME players, right? So a lot of the actors in the solar industry are SMEs, but only in the recent 12, 24 months have we seen the big oil majors now coming into these markets. Lightsource BP, we're looking at Shell, Total, Eni. These people are all starting to make a big. So it's going to be interesting to see what they bring to the industry, because thus far it's been punctuated by startup innovation, innovative companies like Above, like dozens of other ones that are building this ecosystem of software and services. So yeah, I think there's going to be a breeding ground for this for a long time to come, and I think a lot of those big oil majors approach will probably just mop up some of these smaller organizations that are sort of sowing the seeds earlier in the industry.
Well, let's go to one of the big organizations and ask the question then. So Nidhal, what's your perspective on SMEs and innovation startups?
Yeah, as a big organization, we have capabilities. We have one of the biggest R&D organization in the world as well, with lots of capabilities. So we're building our own models, but at the same time, we'll never be able to go as fast as we wish to do. And there's so many models that are developed by tech companies, tech startups that we're using and that are released open source out there. So honestly, maybe 90% of the models that we're applying, we're not developing that. We're taking things that other startups and small companies, businesses have developed and shared with us. And this is, I think, very interesting, because it's an added value in terms of the timing, but also the costing. So we need to work with SMEs, we need to work with startups, we need to work with companies in the IT, but also out of the IT sector. So hopefully we'll be building Sizewell C in the future. So there is lots of application in the construction, maybe a sector, lots of application of AI models that are developed in other sectors that we can learn how to use it and apply it in several of our challenges and our projects as well. What we talked about explainable AI earlier, this is an area where we're not adding anything to the let's say the scientific research. We're using what's out there. We're trying these techniques. We're comparing them in order to be able to apply more explainable techniques on our models. And if we spend time to work on developing the models and in the explainability, I think it's going to take us months before we attend a project that is meant to be developed in 1 month. So we need them.
Okay, great. So we've got about 2 minutes left of our allocated time. So I'm going to ask one question, and if all three of you can kind of give your just kind of view, bring them over. We've only got actually a minute now. Is what's the one single thing in the energy sector where you think AI will have the most impact? Right, and Andy, I'll go to you first on that one.
I think in terms of what we're looking at in terms of being able to look at it from lots of different aspects. So we're looking at repeatable AI, so we can look at shipping, we can look at heavy industry, we can look at hospitals, we're even looking at data centers. So I think if you can make it repeatable, then you can benefit significantly from energy efficiency from all sorts of different areas. not necessarily just focusing on perhaps power generation. I think there's lots we can actually do to reduce our energy spend, as opposed to perhaps changing the renewable mix.
Cool, great, thanks. Will, the one big thing, the impact AI is going to have.
It's got to be the total system modeling around weather and supply and demand. I think that's absolutely fundamental and cuts across storage, EVs, renewables, everything. So I think that's a huge prize for the industry.
Great, and Nidhal?
I would go with reinforcement learning for optimization. We talk more and more about battery storage, and we're developing lots of capacities in this space. So in the future, when we will have them, what's the best way? When is it best to use them? When is better for the grid, or when is best for the climate? And I think AI, by learning from human, could be really an added value to that.
Great, thanks very much. Just cognizant we've kind of timed out at this point in time, so I'd like to thank Andy, Will, Nidhal. Thank you very much for your participation in this, and also the openness and honesty of your answers. We got a few more questions here that I just haven't been able to get to. We'll try to get those over to you if you can probably answer them more directly.